Everyone, and welcome to the webinar on tapping into limitless code inspections. I am not Chris. Chris Gardner, our lead developer, is running the webinar. I'm just going to give a quick introduction. My name is Dave Millington, and I work as one of the product managers here at Ultimative and Idera. Chris, would you mind going on to the next slide, please?
Absolutely. There might be a bit of delay.
Fantastic, thanks. I think there is a bit of a delay here. But that's okay, because I can see people are still coming in, still joining, so that's all fine. Look, I just want to give a quick introduction to Visual Assist. I don't know if you already know it, most likely all of you since you joined the webinar, so this will be short. But it also gives a bit of context as to why we're focusing on code inspections, particularly in this webinar. And as you most likely already know, I mean, Visual Assist is a productivity-focused plugin for Visual Studio. Most recently, Visual Studio 2022, when we 64-bitized it to match the 64-bit version of Visual Studio. And it's heavily focused around what we can do with our code parser and our engine, and traditionally is focused around navigation or searching or finding or something like that. And in fact, many customers that we talk to are used exclusively for that kind of functionality. You can see some screenshots on screen about find references, for example, or find symbol. Or in the top right, one of the more interesting features, investigating a symbol and the types that go into that symbol so that you can navigate to them. But we have a lot of other features as well. The snippet editor, for example, is also on screen. Next slide, please, Chris. And so we aren't focused entirely on this kind of thing. We actually have a lot of other features. Here are a few more screenshots. The VA view is something that you may have docked permanently. Many customers do, and it's really excellent for navigation. And you can see a context menu on screen that shows a lot of our other functions as well. Open file and solution, which is the top menu item on that menu, is one of our most popular features. But you can see many of the others, and again, it's often thought of as a product that's around navigation. So if you look at that menu, you can see, go to implementation or go to related, or other features that are sort of related to code navigation. Next slide, please. I think there is a delay there as well.
I'm sorry.
No worries. I think GoToWebinar does this sometimes. Now, we do want to focus on other things in this webinar that are not the features that many people already use in Visual Assist, and that's why we're doing a webinar on code inspections. Now, Visual Assist has a few sort of things in its ethos, in its DNA. One interesting thing is that it's always been built to sort of fill the gaps in Visual Studio. So all of us on the team are developers, and there's sort of a catchphrase of by developers for developers, and that's true. And for reasons like that, we also value things like the performance and the memory usage and that kind of thing. As developers, I think obviously performance is important for you when using the product, but we also have a lot of pride in the product, and we try to do a good job. You can see a screenshot on the right-hand side where our development team pulled off something absolutely amazing a couple of years ago. Where on some even gigantic projects, 6 million lines of code, it was using only a couple of 100 megabytes, and we even improved performance at the same time. This is the kind of thing that we try to do within the product. And Visual Assist is built around a custom parser, and we'll actually mention this a bit later when we get on to code inspections, but it's quite resilient to errors. There are a couple of, basically two different types of parsers that are used for tools like this. And the most common is a compiler-like parser, which makes sense because you're parsing computer code. But Visual Assist, actually uses a different type of parser, one that's very resilient to errors or very good at sort of looking past errors and understanding code regardless. And that's very important because when you're in the middle of coding, your code often doesn't compile. You're partway through doing something. And so a compiler like parser is not really suitable for something when you're in the middle of development. It's fine for analysis of code, and we'll actually get to that with code inspections. But the majority of our functionality, such as the navigations, will work even when you have code that doesn't compile, and that's very deliberate, and it's one of the things we think makes our tool particularly special. But with that introduction, code inspections are a very useful feature that we've widely expanded in the most recent release, but they're lots less known than some of our more core features that I just went over. But they're really good for assisting your code quality. Yeah, that's the focus of today. So next slide, please, Chris.
Alrighty, I think that's it's my turn now. So
awesome.
David,
over to you then.
Thank you very much for the introduction. And sorry for the little message there. I got to make sure to close everything I could potentially get messages from. Sometimes I forget something. Okay. So thank you again. We at Ultimator are just very excited to bring you Visual Assist 2023.2, and we've been very hard at work to bring you a packed release. So this is a big one for us, and we of course intend to have many more packed releases in the future. But this is something that we thought it was worth spending some time to talk about because some of these features we think that because they've been in beta for a while or they're relatively new. There's just a lot more value that people could be getting out of them. So we're going to talk a little bit about them today. So new in Visual Assist 2023.2 is a major rewrite of our shader language support backend. So in the code, we changed just everything about how it worked essentially, and this was mainly focused on fixing issues that users reported to us. And I haven't talked much about shader support before, so we're going to spend some time on that today. We also added over 100 new code inspection checkers. Now, these are unevaluated checkers, and I'll get into what that means later and how to access them. Another topic we'll discuss today is our integrated menu, which is a new optional mode that makes it easier for you to access your plugins. I'll explain how that works. And if you just generally, if you haven't given 2023.2 a shot yet, you can try it for free by downloading it from our website, and I certainly recommend that. Even if you've tried VA before or you're not in maintenance or whatever, you get 7 days to try Visual Assist and use it for every new build. So whenever a new build comes out, if you want to just try it for 7 days, you get the 7 days, even if you're out of maintenance. So give it a shot. Maybe even if you're out of maintenance, you'll find that it's worth renewing for. And near the end of the webinar, I'll be giving a short demo of these features. And if you have any questions, you can ask them in the questions panel. It looks like we might already have some action there. And we'll have some dedicated time later for questions and answers after the demo. All right. So let's get started on code inspections. If you don't know what code inspections is, that's fine. I'll be describing what it can do for you before we get into how to use the new checkers. So code inspections in 2023.2 is now finally out of beta. It's been very deeply tested in many code bases now, and for years, frankly, and we now feel more than confident that it's ready to help everyone write better code. Many people have used code inspections, many large companies, to improve their code base and to improve their code. We're very happy with how it's going. So I'll get more into that soon. We have added over 100 new unevaluated checkers to code inspections, but put simply, unevaluated checkers just haven't been evaluated by our team. I'll get into a little bit more detail soon about what that means and how it's different than the code inspections that we already have. Keep in mind that code inspections is disabled by default. So if you want to try code inspections, enable it in the Visual Assist X menu. There's a few reasons for that. The main reason we have it disabled by default is maybe you aren't refactoring. You know, not every, I understand like every engineer loves to refactor their code, but not all the time do we get the opportunity to, depending on what the lead decides. If the lead says no refactoring, just work on what you're working on, then maybe you don't want it enabled. But it's great to enable it even just for the code you're working on, so you can check new code that you're writing and make sure that it is up to par. So just give it a shot. It's a really great feature, and it's worth enabling in our options dialog in the Visual Assist X menu. So you go to Visual Assist X code inspections and then just enable. And you can also show the code inspection results window from there. We'll talk a little bit about that. So if you're new to code inspections, it basically does three important things. It highlights issues in your code without getting in your way. It suggests fixes for those issues when you hover over a problem, and it can refactor the problem for you. It's as simple as that, and we'll get into what that looks like in practice. You can see in the editor window, we have a few blue underlines. These are the code issues that Code Inspection has found as you edit your code. So it's basically working in the document that you have open. And you can see the suggested fix in the bottom left. So right here, we've clicked, if you hover with your mouse, a little tomato will appear. You click the tomato, or you hit Shift-Alt-Q. There's a couple of different ways to access this. You can see the suggested fix. So in this case, the fix is to avoid the old copy and swap trick when shrinking vectors. So it's more of like a lot of code inspections is built around modernization. So for example, this old copy and swap trick was the best way you had to shrink a vector for a long time, but now there's a better way to do it. So you can use that, and we can actually implement that for you. And on the right is a list of all code inspections we found in the file. So if you open the code inspection results window, you can get a list, you can sort it, you can apply all the fixes at once to a file, etc. It's a very, very powerful window. And some fixes, some checkers don't actually appear in the editor, won't be underlines, but will only appear here. That's going to be important when we talk about unevaluated checkers later. So Code Inspections has over 40 checkers built in, and we're adding more almost every release. As new C++ standards come out every few years, certainly keeping, I left one thing open. Okay, as new C++ standards come out every few years, keeping your code up to date can spend a lot of effort, right? I mean, like all of a sudden now you need to go back and refactor a ton of code manually, make sure you don't add bugs, make sure you do it correctly. It can be a huge pain. And ultimately what it tends to result in is code stagnating a bit. So this is one excellent use of code inspections because it can there's many checkers in code inspections to modernize the way you use C++. But besides that, we also aim to catch common performance drains and potentially buggy mistakes, such as stood string constructor call below. This right here. This example, what basically the parameters are swapped. So it's hard to tell if you're not very, very versed in strings, because this will compile and it will run, but it won't do what you expect it to do. So we'll catch things like that. And indeed, that's the focus of code inspections, coding issues that the compiler alone won't catch. So each of the 40 plus vetted checkers is carefully chosen to be highly relevant and helpful, and it won't add noise to your workflow. So you won't find, so just going back up, you won't find things in this list are just like noise, like, yeah, that's kind of a minor, I don't even care about that. This is going to be important and useful and worth actually changing. That's very important. It's not like a full, we didn't design this to be a full linter, because we don't want it to be noise. We want it to be something that actually is valuable for when you're working, although we'll get back to full linting later. Internally, we use Clang to power code inspections, and that's the LLVM dragon, that's the Clang dragon right there. Each of the vetted checkers that we run through Clang is carefully tested and maintained to ensure you can trust our implementations. We won't break your code, and you can apply all fixes to a file without any stress at all. You can apply them to your entire solution, one file at a time, without any stress at all. We want developers to trust this feature, and we understand that trust is easily broken. So all vetted checkers also come with built-in refactorings, so we can quickly fix the issues for you. However, some developers have asked for more, and that's what 2023.2 is offering today in the form of unevaluated checkers. So 2023.2 includes over 100 new unevaluated checkers. So you'll have the full power of all the possible unevaluated Clang checkers available through code inspections. To access unevaluated checkers, click the Show Unevaluated Checkers checkbox in the Code Inspections tab of our Options dialog. So you can see here what it looks like to click unevaluated checkers. You'll get a very long list of unevaluated checkers. The default level is unevaluated, which essentially means that they'll appear in the, let me scroll up a bit, they'll appear in this window, but they won't actually muddy up the editor window. And when I do the demo to explain, to show this, you'll understand why that's helpful. But you can actually change the level. If it's something that you want to actually show up, you can change the level and it'll turn into an underline or such, whatever you'd like. So it's very flexible. Now, it's important again to reiterate that unevaluated checkers have not been through the rigorous testing and improvement process that we do for all of our vetted checkers. There are more of them, but they could break your code, they could not work properly, they might not be highly relevant or frequently, and could add a lot of noise to your coding workflow. And many actually aren't able to do refactorings for you. So with those limitations in mind, how do you get the most out of these unevaluated checkers? For a few different use cases. One use case is if you just turn them all on, you'll get something akin to like full code linting. So like a linter that shows just all kinds of issues. You'll see lots of issues, even in well-written code. It'll be a little overwhelming, but by default, unevaluated checkers don't create underlines in your editor window, as I've said. So it can be a good learning tool. It can be just good if you want to just go, if you just want to see everything. And scrolling back up again, you can actually sort this. This window is sortable by code level. So you can sort this so that you can have the unevaluated checkers sorted below, and you can have all the more important checkers sorted up top. So that's one way to use it. Let's go back down. All right. Another use for unevaluated checkers is, let's say you're an expert in Clang and you already know of some specific checker which you've always wanted, but we've not vetted yet. So you can turn on that specific unevaluated checker to get benefits of that without needing to wait for us. But it's important to note that it might not work as well as we'd like. So if you know of an unevaluated checker that you wish was part of our vetted system, send us a note to support@wholetomato.com and we can prioritize including that in future builds, because we know that there are plenty of Clang experts out there who probably have some favorite checks that they would like to see implemented by default into the product. And finally, if you work on something like Android or some specific API that's supported by the unevaluated checkers, then this is a good way to get that additional support. We prioritize vetting checkers that are more generally useful for everyone, so you can squeeze out a bit more power by customizing code inspections to your environment in this way. As long as you keep these limitations in mind when working with unevaluated checkers, it can be an extremely powerful tool. So we're really excited about that. And I'll show a little bit about how that works and how to configure that when we do the demo. All right, so now that we've wrapped up our discussion of code inspections, let's talk a little bit about our relatively new shader support. For the longest time, users have been hacking Visual Assist to parse shader files. And the reason is HLSL, a common shader language, is very similar to C++, so people were just essentially parsing it as like adding it as a C++ header and source file and such. So we finally went and made that officially supported. We did that in 2022. However, that was the feature was very in beta. It was only one step above the hacks that users would do on their own. But Visual Assist shader support allows you now to access all of the powerful tools in Visual Assist while working in shader files. So both HLSL and Unreal Engine's custom HLSL files are currently supported, which is that USF USH. If you use a custom extension, which many people do, it's very easy to set that in our options dialog as well and get that get the Visual Assist features in whatever version of whatever HLSL you're using and wherever you're using it. So for shaders in 2023.2, we spent a lot of time improving the user experience. The issues reported to us should be resolved, and we're looking forward to implementing more features and putting more polish on this. In fact, we're nearly ready to exit the beta phase. So because of that, I want to encourage everyone to give this feature a shot if you've written shaders before, because it's a very, very powerful addition for game developers. And as this feature is in beta, it is disabled by default. So take a look at the Game Development tab in our Visual Assist Options dialog to turn it on. Again, if you have any feedback about our shader support, send us a line at support@wholetomato.com. Your feedback has been critical so far in getting us where we are today. So as we get ready to exit this beta phase, we want to hear even more from users to make sure that we're hitting all the important marks to get that support as solid as it can possibly be, because people have been using us, like I said, for shaders for so long. It's time to take it seriously. All right, so something else I want to talk, and we're moving quickly, but something else I want to talk about today is our new integrated menu option for Visual Studio 2022 and 2019. If you don't use many plugins, we can remove the extensions menu item and place all extensions into the toolbar. The Manage Extensions menu item is swapped over to Tools, and it's very much like it was earlier in Visual Studio 2019's life. This makes it much faster to access your plugins and avoid having the extensions menu take up precious toolbar space. You can see what that looks like here. This is Visual Studio 2022, where I'm showing this. So normally there would be an extensions, and there would be Visual Assist X, and you'd have to kind of click through there in order to get to us. So you don't have to do that anymore. It makes it much faster to access your plugins. Like many of Visual Assist features, this one is disabled by default. Check out the display tab of our options dialog to turn it on. And it's just as an example, you'll be able to access Visual Assist's menu with a single shortcut, just Alt-X instead of Alt-XX, which isn't too much harder, but also if you're a mouse user, it becomes a single click. So in a sense, that's twice as fast and twice as efficient for you. If you like to use the mouse and you like to click the VAssistX menu, this is great. And it's different from the built-in option. The built-in option allows you to move items out of extensions, but even if extensions menu is empty, it still sits there. It still uses space. So this gets rid of that. It moves everything out just very cleanly. And if you have a lot of extensions, that could pollute the toolbar, but if you don't have a lot, then this makes a lot of sense. So, so you can give that a shot. All right, so now we're going to do a quick live demo where I'll show you a little bit about how to use unevaluated checkers and how our shader support works. So let's jump into this. Okay, so if you go into Visual Assist X and jump into our options dialog, if you go to our game development window, you'll see enable support for shader files. It's currently beta. I don't know if we actually still require a restart anymore. We might not. I certainly would like to get rid of that before we get out of beta if we can. As part of the rewrite, we might have removed it necessary. But you can see the default extensions that we have here, and you can simply add your own. And once you enable that, you'll see that things like USH, USF, and of course HLSL all are now colored. And our features work, and you can do simple things like rename and all that. All those powerful features, you now have the ability to utilize those in shader files, which is great because a lot of games have a lot of handwritten shader files, and there can be quite a lot of code. They can really explode in the number of codes, and being able to have basic access to refactoring and such is very critical. So you have access to that now. And you know, not just for HLSL, but of course these custom shaders as well. It's just so nice to be able to have access to something that's you know, you've got all the IntelliSense-like features from Visual Assist that you've come to expect, as well as more, now available in shaders. So we're really excited about that. Another thing is you can see right here, this is Visual Studio 2022, and I don't have an extensions menu. That's because I've enabled this, switch to integrated main menu. I can turn that off, and we'll see what it looks like otherwise. Normally we have this extensions menu, Visual Assist X, manage extensions and such. But if you turn it on and go back, now the extensions menu is gone, and VAssist X is now in the top level menu. And if you want to manage extensions, you can do it through tools, much like it was earlier in Visual Studio 2019's lifetime. So if you've used an older version of Visual Studio or Visual Studio 2019 before they made this change, this will be very familiar to you. Very familiar. All right, let's move on to shader support. I'm sorry, code inspections. All right, so just a basic demo of code inspections. We can see the blue underlines, we can see the tomatoes, just like I was talking about. If you click tomatoes, we get suggestions, and if we accept the suggestions, it refactors for us. We can do that for all kinds of suggestions. It's very simple to do. You can also apply suggestions from within the code inspections results window. You can even apply everything all at once and get all that taken care of immediately. Now, that's just basic code inspections. Now, let's take a look at what it looks like to turn on uncheckers. This is very highly scaled, so this would normally be a little bit easier to read in a sense. You'd be able to see a little bit more, but considering I have this at over 300% just to make it easier for y'all to see, it's a little bit harder to see, and it's going to be particularly hard when we turn on unevaluated checkers. So I'm going to check that, and now the list explodes with so many unevaluated checkers. So one thing, I'm just gonna enable everything. I'm gonna enable everything and show you what that looks like. So even in this small test file that's decently well written, we'll actually end up with many code issues. Let's see. Oh yes. Oh goodness. So I'm going to go ahead and change the sort and group by level. So grouping by level, like I said, is very powerful because it allows you to separate unevaluated checkers. You can even and you can see separately at the bottom here unevaluated checkers and then the checkers that we have that are vetted. Now, unevaluated checkers often won't have fixes. So for example, here, the little icon here, the bulb means that this has a refactoring available for it. Not all of them will have that. And you can see just the multitude. We have 61 unevaluated issues. Many of these aren't that important or may not be relevant, but it's basically giving you the full linting power of code inspection. So this is actually incredibly powerful and it's worth taking a look at. But it is quite a bit. But you can also notice that these unevaluated checkers are separated. It's not one of the normal levels, and it doesn't show up like this right here. It doesn't show up as a blue underline, so it won't actually mess things up. If you like one of these checkers a lot, what you can do is let me go ahead and reset to default. Okay. And then let me go ahead and grab some unevaluated checkers. So let's say I want this checker. So I'm going to enable it and I can change the level. So if you change its level, then now it'll show up as underlined. So basically you can make these first party checkers. Like for example, let's say I'm an Android developer. I can search for Android and I can see that there's several code inspections. There's several checkers here that are specifically for Android development. So I can enable all of those and I can change the level to all of them to 3 or to 4 or something like that. And now if I'm working in an Android code base, this can help me quite a lot. Now, there's no Android code in my test, so there's no issues that are being found. But that's the basic idea of how you can use unevaluated checkers to make your system more powerful. And when you go back here, you can turn off show unevaluated checkers, and anything that you've selected or changed or modified or enabled still shows up. So even though these are unevaluated checkers, they'll still show up even though unevaluated checkers is disabled. So we'll still see them. There's a little line that separates the vetted from the unvetted, and you can see the unevaluated checkers there. All right, so that's been our very quick walkthrough of this new release of Visual Assist. We have time for questions. We have certainly a lot of time for questions. So let's take a look. Do we have anything that users have sent in?
We do have some questions here, so I can run through those. The very first one, actually, I can probably answer, which is whether we offer a plugin for Visual Studio Code as well. And the answer is no, we don't. It's Visual Studio for Windows only currently. Although we are researching it. Visual Studio Code's extension model is very limited, or perhaps good to say that it's designed for very specific sort of extension. It's very inflexible. So if you want to do what they wrote the extension model for, you're fine. But if you want to actually, really extend it, it's very difficult. Which I think is a pity for such a wonderful IDE. So it does mean that Visual Studio Code is not built for the kind of features that we add. That said, we are looking at what we can, what we can do. So the answer is yeah, not currently, but something that's under consideration. Chris, a question for you. This actually isn't strictly related to code inspections, but it's about dark mode, and it's a comment that the menu options in dark mode are hard to detect, and the question is whether that could be improved to be a bit easier to see, maybe with a marker. And an example was enabling code inspections, that if the monitor is dimmed and in dark mode, it's difficult to see the difference between on and off.
I agree. So that was something that's basically a UI decision that was made by the Visual Studio team. But that's good feedback. I think what we should do is just, since we have control of how we render our own icons, we're currently just allowing Visual Studio to handle it. We need to do better. We could probably just put like a box, like a little box or something around to highlight that this is enabled or disabled. So I agree with you. That's something we could fix. That's good feedback. And I do agree. I do agree. It can be kind of hard to tell.
Yeah, thanks as well, because that kind of feedback is really good, because it's something we can improve, and clarity is important. Just as a general note for everyone, if you have any feature requests or anything like that, like this or anything else, there could be much larger ones as well, drop us a line at support@ultimator.com, because that goes directly to the team, and we'll see it. And we really welcome requests and bug reports. We hope not to get too many bug reports, but if you encounter bugs, we love hearing about it, because we want to fix it. So yeah, support@ultimator.com is a great path there.
Absolutely.
There's another question, Chris. Are we going to support GLSL?
So we do have plans to look into that. We're looking at, two things we're looking at right now are CUDA. So if you know about that, it's basically allows you to use C++ to interface with the GPU. It's popular, like among machine learning and stuff like that. So that's one thing we're looking at adding official support for, and GLSL is the other one. So yes, we are interested in that. We definitely are, because we know, like I said, people have been using our product on those languages for some time by just kind of hacking it. So now we need to go through and get official support. So we are looking into it. I don't have a timeline for when that would be released, because I'm not sure all the difficulties that we're going to encounter yet, but we are evaluating that. So we're certainly interested in it. It's on our list.
All righty, thanks. Next question is it possible to show a preview for which changes code inspection will make? And the example given is that the person who asks has some old code with warnings about not initializing all members. And if they use, not certain I understand this, sorry, but if they use the automatic, then it doesn't always work correctly, but they can do it by themselves. So,
interesting. So I'd be interested in hearing feedback about how we're failing you there, because we really want to create trust with all of these checks. So a lot of the feedback that we've gotten is a lot of developers just can apply everything without having to think about it. But if we're doing something that you think is inappropriate at any point, then I would absolutely, as long as it's an evaluated checker, a vetted checker. If the unevaluated checker, but vetted checkers, we expect those to work perfectly every time. We spend a lot of time making sure that working on those and testing them, and we test them before every release. We do quite a bit of work on those. So if it's not working properly, then that's important. But here's what I would do. The answer is no, that there is no built-in way to see what we're going to modify ahead of time. So because like I said, we want this to just work. We don't want you to have that extra step. But if you need that extra step for some reason, I would just use I would just use a diff tool and say, like, for example, for me, I use Perforce. So I would save the file and just Control D in Perforce to get the diff, and I would see everything that changed. That's one way. That's probably not perfect. Like I said, we're trying to design the tool so it doesn't ever need anything like that. So my feedback is twofold. One, you can use diff That's what I would do. And two, please send a report in so that we can, get that working better for you, because we definitely want that to work without you having to worry about it.
All right, thanks. Yeah, there are a few other questions. So, yeah, on code inspections, do they help safety, as in security?
In some cases. So some mistakes can be dangerous. Even something as simple as using a null pointer versus null. So zero constant can be replaced with null pointer, can slightly improve safety. Replacing for loops with different types of loops can improve safety. There are certain things that we do that can improve safety. It's not, or for example, like swapping, like having a string where you swapped the arguments. Certainly, we do issues like that. We don't have a major focus on code safety, like for example, checking if you haven't freed memory or something. That's pretty tricky and not something that we specialize in, at the very least, not yet. So some things indirectly related to that, yes, but not so much directly, because it can be hard to check those. The compiler, for example, will miss those. Yeah. There's so many ways to shoot yourself in the foot with C++. Geez, we'd have to have thousands of checkers.
I think a related question one is, can you give some examples of code inspections that are, ones you particularly like or particularly useful? And I think there actually it'd probably be good to look at the evaluated ones, because they're the ones our team has, added first. But are there any that, you can sort of show, Chris, that are particularly nice inspections?
For example, I actually, this is silly, but I like raw string literals. I just hate having to have multiple slashes everywhere. So the ability to convert stuff to raw string literals is actually really nice. And that kind of goes for all of this stuff. I like using modern C++. I like staying close to the standards as possible. That helps the compiler, that helps the code to run smoothly, and it helps us be consistent across the board. So just anything that helps bring us up to modernization. And there's so many different, and I know that maybe that's just kind of generic answer, but it's just so important to just keep your code modern and just have a very easy way. So, maybe you don't even know about in-place spec. We'll fix that for you. Maybe you don't know that needs to be a const reference. Maybe you don't know about the range-based for loop and how much simpler that can look. Maybe you don't realize that this can be make shared. So just a lot of little things like that helps you have consistency across your code base, that helps you consistently use modern features of C++ and to make it easy for you. That's what I like. That's why this is a major target for us, is just modernization. So for me, that's what would be my call out. I certainly, out of the list of 40, I don't think there's any that I want to call out too specifically, but just the breadth of what we do to modernize your code and keep that consistent. That's what I really enjoy. That's how I use it in our own product. And that's how we've heard a lot of our users, the feedback from users we've gotten, that's what they like. So consistent usage across your product of modern standards is something that I love. And I think that that's a very important use of code inspections, and something that I would want to call out.
I think that's really, a good answer. And I think the modernization something is something that appeals to me as well, because, I often see people with really large code bases, because they've probably started writing in C++ in, the 90s perhaps, or something like that. And, a lot of C++ can be quite old style when it's been written like that, and a lot of code inspections that really help, make the source code itself safer and more understandable and more clear. I can see on screen, for example, about an integer literal being replaced with false, or a zero constant being replaced with null pointer, and I think that kind of thing is good code style. There were others that I saw earlier, which is about shrinking a container, and you used to have to do the swap trick. I remember when I was learning C++, and that was about 2004 or something, it made no sense to me at all why you had to do that. You know, why wasn't there
Yeah.
something in the STL to do that? It took a long time to get added, but now it is there, and so you have a code inspection that will go and fix that. And yeah, things like that are, I mean, to me, really good. It just sort of cleans your code up. You know, it makes it more readable, and you know, uses the things that have been added to C++ that just make it a you know, more polished language. Which I think is basically what you were saying as well, Chris. But yeah, I just
Yeah,
wanted
yeah.
to
And
emphasize
you
that
can
because
apply them in
think
bulk, and that way you can have consistency. So another problem with code bases is a lot of times you end up stuck with an old style of doing things. And the reason is because sometimes it's better to stick with an old, somewhat wonky way of doing things, just because that way you have consistency, because consistency is important. This tool allows you to have consistency because it's so easy to fix old code while also using the latest standards. So that's really critical for me. That's one of the things that we've really tried to hit the target on with code inspections.
another question here, which is what does unevaluated mean?
So,
So
okay.
it's the difference between the questions, and it goes on to say, if I use the new code inspections, is there any risk?
So yes. So if you use unevaluated code inspections, there is risk. If you use vetted code, so if you check this, so let me go in. If you use unevaluated checkers, there is some risk. That means, so for all the evaluated checkers, we spend a ton of time writing unit tests for them, writing, you know, going through the code and changing it and improving the way that they work and performance and how they hit, to make sure that they don't break code, to make sure that they're functional and they work and that they're relevant, et cetera, et cetera, et cetera. We've done none of that for unevaluated checkers. So it's a little bit of an advanced feature. It won't explode your code, but it's possible that it'll generate code that might not be to your liking. It's possible that it'll generate code, if it even has a fix available, that won't compile. These are possibilities, absolutely. So so I wouldn't just enable them and just apply as many of as possible. That's not what that's for. That's not what we would recommend. That's only for vetted checkers. That's why we have the vetting system. And that's a huge there's a big difference between the vetted and unevaluated checkers, and that is the difference. Now that doesn't mean that that there's no use case for unevaluated checkers. There certainly is, but you need to be more careful when dealing with them. You'll need to actually, it's worth double checking your work in that case, the double checking the change. I wouldn't apply a bunch of those to a file until you're comfortable with those checkers and what they tend to do. So there's the major difference there.
Yeah, I think one of the things is that you know, these checkers come from Clang, and you know, for a long time we didn't just sort of expose everything that was available because, as Chris said, we wanted to be very certain that what we added was correct. So we went through them all, and as Chris said, really well vetted them, and that's why we use that term. You know, we've tweaked them and made sure that they're, you know, is safe and powerful. But it did limit us a little in that we had, you know, 40 checkers that we were very confident of, and there were another 100 or so that we could have exposed that we didn't, because we hadn't been able to spend that time to, you know, to verify their safety. And so that's one reason why we turn them on this release, you know, to make, because they are there and they are useful, and so we want to make them available without hiding them. It's just that, you know, I don't know, some tools just sort of throw everything in and then have a big feature list and say, oh, here it is. And we try to have a different ethos, which is that we try to, you know, as part of, I guess, the being written by devs for devs thing is that we try to be very certain that we, you know, what we make available is very high quality. And that's why we have the differentiation between the vetted and the unvetted. The unvetted ones are there and they're part of Clang and they're, you know, potentially useful to you, but you do need to take a bit of care. Whereas the vetted ones, you know, are ones that we have, you know, we have taken that care effectively, and put a lot of time into making sure are safe. Effectively using the unvetted ones, you know, the new ones, is the same as running Clang on your code anyway. It's not going to be nearly as good as using Visual Assist because we have all the vetted, the additional sort of safety and correctness that we've put in. But on the other hand, having the extra 100 there can be useful because there are useful ones in there.
Yeah, it makes it work a little bit more like a linter, and whereas the main focus of code inspections is to be there kind of while you're editing and while you're working, highly relevant, whereas a linter kind of throws everything at the wall. This allows you to kind of do something in between, but you'll have to be a little bit more astute to what's happening in your code. Whereas if you're using just vetted checkers, you can apply them anywhere you see them, and you don't even have to think twice. You're ready to check in. That's our goal. And I think that we've hit that goal.
Question here, Chris, about Visual Assist being used with C#. And the questioner notes that code inspections appear to be C or C++ only, but asking what other parts of Visual Assist work with C#.
Okay, so code inspections, you're right. That's a keen eye. Code inspections is C++ only. Visual Assist mainly focuses in C++ because that's where we find the tooling is most lacking. However, basically every feature of Visual Assist except for code inspections works in C#. So we ourselves use C# quite a bit in our code. Even though our product is C++ at its core, we interface to Visual Studio through C#. A lot of our UI is done, through C#, et cetera, et cetera. So we get that there's, and that's a really common thing. To have this interface between C++ and C#. So we do support C# with basically every one of our navigation, refactoring, and all that features. And we plan to bring more support to C#. We've improved our C#. We've been making improvements to our C# parser and such to make sure that we support the latest standards. So you can expect the vast majority of Visual Assist to just work in C#. But unfortunately, code inspections is one of the few exceptions. Yeah.
There's a question if it's possible to check multiple files at once.
So at the moment, you can it can check like a couple of files at once, like headers and includes. But at the moment, it's just the file the file or files you're working on. So it's meant to be as you're editing. We do have plans in the future to expand code inspections to allow you to vet, for example, to check your whole solution at once and such. But we're still working towards that. We're making sure that everything that we do is carefully planned and won't break code inspections because we're really super happy with it now. It's been tested for years as it is, but we do have plans to do that. It's on our roadmap, but it is not currently part of code inspection. So for now, essentially it's one file at a time, the file that you're working on, and as you're editing code, as you're writing code, it'll check as you're working.
So a question here that was a follow-up from the one about the verification process. We discussed it, vetted versus unvetted, and that a lot of the checkers come from Clang. The question is, as a follow-up to that, does Clang LLVM do testing of their own for these checks?
Well, as much testing as an open source product does, you know what I mean? So I from experience, I can tell you that a little. But basically every single checker that we have vetted, we've changed the code of, so at least some. So expect there to be some rough edges. But like I said, that's just what you get when you're working with unvetted checkers. While I don't claim to know the processes that Clang goes through to accept these those open source checkers. It's not nearly as much time has been spent investigating these and making sure that they work the way that. And another thing is Clang kind of there's with open source, you've kind of got this thing of let's just throw everything at the wall. Let's make a linter. But we have a slightly different take on things. So it really is. Just to answer your question, no, they don't do as much testing, not nearly as much as we do. And like I said, basically every inspection that we've adopted or created, we've spent a lot of work and it's almost certainly edited code. It's changed in numerous ways. And we've certainly there's been checkers that we've liked that just were broken, that we didn't like. New versions of Clang come out and they break checkers, and all that stuff we check for it and fix in VA's releases, but you won't get that benefit with unvetted checkers. And certainly Clang just doesn't have the time and the manpower to do all that, but we do.
All right, there's a question here that's again unrelated to code inspections, but a good question. It's about is there anything new in the 2023.2 update for C++ development in Unreal?
Remember, let me check. Do we do anything for Unreal here?
We tend to do stuff for Unreal most releases, and I think 2023.2 happened to be one of the ones where we didn't. So it's actually an awkward question to ask.
Yeah, no, I think this is one of the ones where we didn't. I think that what you could say is that the shader support, a lot of that is for our Unreal devs, but of course it's for anyone that writes HLSL. So, in a sense, yeah, I mean, our support for Unreal Engine shader files and such, and that was a big kind of that was a big testing ground for us as we worked on this release. So not directly, but certainly indirectly. We always have Unreal in mind.
Yeah, the parser support, I mean, the shader support was originally out in 2023.1 a few months ago. We've just sort of kept on expanding it and improving it in the most recent release. So yeah, as Chris said, Unreal Engine is always present for us because a lot of people use Visual Assist with Unreal. And again, 2023.2 is perhaps a bad example because in 2023.1 we added a lot more C++ stuff. For example, we had several new language features around auto type detection and structured bindings and so forth. So big C++ focus there. And actually, that reminds me, a few minutes ago, there was a question about using Visual Assist with C#. And in the same release, we added parser support for C# tuple deconstruction. So that just echoes that yes, Visual Assist is definitely supports C# as well, and we're adding things for that language as well. Look, I think we've reached the end of the questions. I actually can't see any more coming in.
Right. Well, in that case, to anyone who's made it this far into the presentation, thank you. And if you have any questions for us after that, we're certainly happy to take them. You can send them off to support@holtomato.com. That's kind of a generic email that's for not just support, but for feature requests, for general questions, anything. Just send it over, and I see those. And of course, our support person is extremely well versed not only in Visual Assist but in C++ and C# and all that. So we'll be able to get you high quality answers quickly. So thanks again. If there's any last words you have, David, for us?
Actually, there was one question that I missed. Sorry about that.
Okay.
The question is, what do the levels under the code inspection menu signify?
Okay, so basically, let's go to this. So a couple of things. Levels basically signify, they allow you to sort. Lower level means more important. And more important generally means it's going to be more visible in the editor. So for example, level 3 will have this blue underline, a level 4 has this little green underline, and a level 5 is generally less visible. So an unevaluated level means it doesn't appear at all. So it basically changes how things are displayed. It also gives you a sorting capacity. So that's basically what levels are. I think my plan is to kind of simplify this a little bit. I don't think we need quite as many levels as we have, but we do. And yeah, it mostly changes how they're displayed in the editor. So for example, this slightly darker color is the level 5. It's not even underlined or anything. It's just slightly slightly noted here. So that's the main difference that levels make.
All right, thanks. And I think this time, really, there are no more questions. Sorry for missing that one earlier, but I'm glad I caught it.
Yeah, we appreciate all your questions.
All right, so I think we should probably wrap up then. And Chris, you were about to do that when I.
Oh, well,
question.
I'll just say it again. Thank you everyone for attending. Hope you enjoyed the webinar. And again, if you have any questions, send it over to support. Thank you and goodbye.
Great, thanks very much. Have a good day.